Alrighty guys, we left off writing a menu-driven program. It just displayed a list of materials and then used that material to pick a density. So the menu is a list of choices on the screen. Menus can be implemented using if-else-if statements. Now it's kind to repeat our code until the user chooses to exit. And so we're going to write an itty-bitty little program that does that. We could just modify the one with the elements, but we're going to kind of structure it the same way. Not going to actually be the same though. Remind me, did we use numbers for our choices or not? Yeah, we used numbers, right? Press 1 for ice, 2 for, okay. So what we're going to do is we're going to modify so that if you type in a -1, it exits the program. Otherwise, it continues to run, in case you wanted to run it over and over and over. So I did a new project. I'm going to go to source files, add a new item, June 20.cpp. Sorry for the guys listening to this. I'm having to move the mic around. The mouse keeps hitting it. Alrighty. Go to Boilerplate Iostream. String, capital S-T-R-I-N-G. Using namespace std. Int main. System pause if you're on Windows. And I want to show you another system command, by the way. I'm going to this isn't part of what we're going to be doing, but I'm going to print a message, and then I'm going to call system clear. System parentheses quote clear. This is a really bad way to handle the clearing of the screen. But when it runs, oh, didn't work. That's because that's a Linux command. Is it CLS? Yeah, okay. System CLS if you're on Windows. So what we see is that it erases screen. If you wanted to make a program that would erase, you typed in some stuff and then you wanted to erase the screen so that they could type in some more on a blank slate or something like that, you could do system CLS. Is that a tacky way of doing it? Yeah, that's a real tacky way. Let's find a better way. C++ Iostream clear screen. To clear the screen in Visual C++, use the code systemcls. That's really lame. There's got to be a better way. Okay, so here we go. The simple answer is calling system clear or systemcls. It's a bad thing. See why system is evil for more. Okay, so the standard way, pathetic, but usually correct. Cout string 100 \n. This works by putting 100 new lines on the display. So it effectively just scrolls everything. There's also the curses library. We don't necessarily have curses. We're on Windows and we're not on Linux. Using conio.h. This library is severely deprecated, but it is so popular that some form of it exists on just about everything. Let's see if we can get this to work. Where's the clear statement in it? Oh, right there, clear screen. Okay, I'm going to give that a shot. I'm going to go in over here, and along with these other includes, # include conio.h. And let's test it out. Let's actually do some print statements like CLIOS, enter your name, colon space, end quote, semicolon. What am I doing there? It's cout. I have CLS in the brain. Cout arrow arrow, enter your name. Let's declare a string called name and read into it with CIN. CIN arrow arrow name. And then we're going to clear the screen. I'm going to have to flip back to the Chrome page to see how we did it. CLR SCR. Okay. So CLR SCR. And then let's print hello. And it says that that doesn't even work. Alrighty. CLR SCR undefined. Is it part of standard IO.h? Okay, C++, CLR, SCR, and then if we don't find it instantly, we're going to leave it. CLR is a non-standard function. Don't use it. I guess that's going to be our answer, is not to use it. Forget it. We're going to skip that. No clearing the screen unless you want to call system CLS, which is considered bad programming. We could write our own function. And then our function could switch between using CLS and CLR depending upon a pound sign defined. But that's really lame. We're just going to delete that. We're going to delete conio.h. I know it's possible, but I'm not going to mess with figuring it out anymore. Okay. I've almost forgotten. I actually have completely forgotten where we were going with this. Let me look at the PowerPoint. Oh, a good old menu-driven program that loops. So get rid of that enter your name business. But let's declare an int called choice. We called it material, I think, actually. And set it equal to 0. And then do this. While material not equal to -1. Let's display our menu. Cout, arrow, arrow, quote, 1 for ice, 2 for aluminum. That's all we're going to put. \n. Cout, arrow, arrow, or -1 to stop. \n. And then, so, if material is equal to 1, we're going to print something out having to do with ice. Ice is cold. Underneath that, we're going to do an else if material is equal to 2. Else space if material equal to 2. Cout, arrow, arrow, aluminum is awesome. \n, end quote, semicolon. Else if material is equal to -1. That's their quit choice. And I didn't put parentheses around it. I was trying to pretend I was in Python. Else if parentheses material equal -1 in parentheses. And you know what? To get all this stuff to fit on the page, I'm going to move my curly braces up next to the if statements. Doesn't change the code, just change the way it looks. Cout, arrow, arrow. Okay, goodbye. \n. And then we need \n, end quote, semicolon. We need one final else to handle that they made a bad choice. Else cout, invalid choice. Try again. \n, end quote, semicolon. I'm not really liking the way this is set up, and I'll show you what I would actually do for a fix in a minute. But this kind of proves the point. Let me close my currently running app. Hey, cool. Oh, what did I do wrong here? Yeah, I don't have a CIN. Let's do that. Alrighty. So after the two couts, CIN arrow arrow into material. Ice is cold. Aluminum is awesome. 3, invalid choice. Try again. I'm getting tired of it, so I press -1. Okay, goodbye. All right, I am pretty happy with the way that works. But one thing that I don't like about it is if you remember the way our program was structured. Does anybody still need to type? Because I'm going to shrink the text down and make it harder to see. Okay, okay. If you remember the way that our program was structured, the if statements all set a density value, which we use later. And this code structure wouldn't support that, right? It wouldn't support setting a density value and then coming down here and doing that, unless we had another statement that said if material not equal to -1. So this works great if the only thing we're doing can be contained within these if statements. What I'm going to do is I'm going to modify it so that if they type in -1, it just breaks. So after that cout, okay, goodbye, semicolon, put a break on the next line, but before the close brace. Break, semicolon. Yeah, E-R-E-A-K. Yep, just the word break. E-R-E-A-K, semicolon.
So after this, you said do a break?
Yeah, do a \n, end quote, semicolon, and then on the next line do break. But actually that one is, the break statement goes on, okay, goodbye.
Okay.
Yep, so move it up. Okay, so I'm going to stick a break here. What break does is it forces it to leave the while loop. It won't execute anything more in the while loop. And if that's the case, I could replace this while statement with what's known as while true, which means just run until it hits a break. So I'm going to do that. It's kind of non-standard, and you're not going to see this in the book, but we're better than the book. While true. You see what I did there? While true. And then down here I have a break statement. That break statement means that everything else is ignored. Now what I actually usually do is I stick the the -1 choice at the very top. Make it blatantly clear that it's going to break, rather than hiding it down here, right? We might have 20 different menu choices like we did on all those elements. So my lastly change to this is going to be to cut this stuff out, that else if material equals -1. I'm going to highlight those 4 or 5 lines, come up here and paste them up at the top, and delete that word else. And if you notice one more little oddity, the program works just fine without it, but technically there ought to be an else in front of that material equals 1. It's just not strictly necessary, because if we break out of it, it doesn't care about these ifs and else ifs anyways. It just leaves the while loop right then and there. All right, if you wanted the program to completely die at that point rather than just exit the while loop, you can use the exit statement that just terminates with extreme prejudice your program. doesn't leave the while loop, the entire program quits. First, let's make sure this leaves, and then we're going to put the exit statement in there. Now, the exit statement is considered poor programming, and what we really should do is just return out of main. But exit can be placed anywhere, not just in main. Let's run this again, make sure it works. All right, I'm going to type in some stuff. Ice, aluminum, 3, invalid choice, -1 to quit. Okay, goodbye. All right, so the code's working the way I want. The while loop keeps running, and I'm assuming everybody's had a fundamentals of programming course. The while loop, that's the condition. In this case, while true means run forever until a break or a return or an exit is found. Let's play with the exit. Before the break statement, I'm going to put exit, parentheses 1, end parentheses, and I'm just going to comment the break out because you don't need to break after an exit. Like I said, exit completely kills the app. All right, and so if I type in -1, the app just flat out goes away. It doesn't get down to execute that system pause. It doesn't get to do anything else. It just terminates it. I wanted you to see it, and then I'm not going to use it. In this case, the better thing to do would be to return out of it. And why did I make it exit 1? So that if there was an error or something, it would return a 1 to the operating system, whereas our bottom statement has always been return 0. So if we were going to write a script, like a bash script or a command processor bat file that ran this program, it could check the return code and make a decision based on that, like whether to send a message to the operator that a program failed. All right, get rid of exit 1, uncomment out break. All right, I'm happy with this. This is how I write my menu-based programs. I display the menu. I immediately check for the exit condition. Now, this exit condition has a very special term. This is called a sentry value. A sentry, is somebody who guards, the castle or whatever. This is kind of the opposite. This is like a sentry who kicks you out of the castle. But it's a special value. That's not part of the normal data allowed. Normal data allowed. I say data. I don't care. Okay, so like if you were going to enter somebody's name, please enter your first name or capital Q to quit, and hopefully your name is in Q. I'm not sure, Star Trek fan. Something like that, right? Enter your test score or -1 to stop. Enter your account number or 9999 to stop. That kind of thing. It's an invalid value that triggers the exit. Not any invalid value should trigger the exit, right? Usually we just want to tell them, hey, that wasn't right, We couldn't look up that name, or, we couldn't find that ID. We couldn't process that test score if it's an invalid value. But a very specific invalid value will cause it to exit. So that's called a sentry value, and we'll see that term again when we get to the chapter on while loops. Why did I show it to you now? Because it makes your menu-based programs more cool. You could test your density program over and over and over without having to rerun it if you do it like this. So menus can be implemented using if-else statements. That's not the only way. So the menu-driven program organization, display a list of numbered or lettered choices, prompt the user to make a selection, test the user selection and expression. If it's a match, execute that code. Otherwise, else if, and check the next one. Else if, else if. All right, validating user input. The idea behind validating user input, and we're not really doing this very much, not nearly as much as we should, is making sure that they've entered something good. Right? If we ask for the patient's temperature and they type in a number below 0, it's probably an invalid patient temperature. And as a matter of fact, we could raise that up. If it's, in Fahrenheit and normal human temperature is 98.6, you're probably dead below 50 or something like that, right? So we can make that a lower limit. And you probably are dead if you have a fever of more than 150. These are huge ranges which aren't even acceptable, right, for real existence, but they would serve. So you could kick out an error message, invalid temperature, that kind of thing. So that's input validation, inspecting the input data to determine whether it is acceptable. Bad output will be produced from bad input. You can perform various tasks. What if it's out of range? You know, you ask them to pick numbers 1 through 4 and they enter a 5. Reasonableness, they entered a temperature of 0 or a test score, you know, of -1 or something like that, or a test score greater than 200, whatever you think your maximum is going to be. And checking for divide by 0. Your program will probably crash if you stick a divide by 0 in there. Let's just prove that to ourselves. I'm going to go up here and at the very top, I'm going to do cout arrow arrow 1 divided by 0 arrow arrow ENDL. Then I'm going to run it. There were build errors. All right, that didn't work. How about I just do int x is equal to 1 divided by 0. Really? What have I done wrong? Error list. Divide or mod by 0. See, it's trying its hardest not to let me divide by 0. It knows it's a problem. We can convince it though. Int z is equal to 0. Int x is equal to 1 divided by z. Surely it can't be smart enough to figure that out. I say that with some trepidation. All right, and it blew up. Unhandled exception. Integer division by 0. Now there's two ways to fix that. One way to fix it is to check to make sure that your value is not 0 before you divide by it. The other is to add something known as an exception handler. And that's a little bit more complex than what we're talking about right now. So the right thing to do would be to just have an if statement, you know, to make sure that the divisor is not, the denominator is not 0. All right, so I'm going to hit break, but it's still running, so I need to hit debug, stop debugging after that. Okay, so that's bad news. You can't divide by 0. Floating point dividing by 0 actually works. Let's prove that. Float z is equal to 0. Float x is equal to 1 divided by z. Cout arrow arrow x arrow arrow ENDL. I'm just going to see what it prints out if we do floating point divide by 0. It says #INF. Infinity to infinity and beyond. So it's a very specific value of a floating point number, but it doesn't cause an exception. If that's the case, I'm not sure why integer division by 0 does, but I didn't pick the way it works. And I'm going to delete that. There's no reason to leave that in the code. I said I was going to delete it. There, managed to. Feel better about myself. All right, here we go. Input validation. Get the test score. Is the test score valid? Is it greater than the minimum score and less than the max score? So if the minimum score is 0 and the maximum score is 100, your teacher never gives bonus credit, then this would not let them in if that wasn't true, right? If they typed in a score that's greater than, if it's less than the min or if it's greater than max, it's not going to get into this good stuff. It's going to display this error message. That is an invalid score. Run the program again and enter a good value. Comparing characters and strings. All right, when you compare two strings, if you check to see if one is less than the other, it uses Ascii values for those comparisons. And what does that really mean? It means that they get sorted in a funny way. If we go and look at the Ascii chart, so I'm going to go to asciitable.com. We will see that all the numbers are before any of the letters and that all the capitals are before any of the lowercase. And you'll see that some punctuation is less than the numbers and some punctuation is greater than the numbers. Why would you be sorting things based on strings? Like song titles, right? You're writing an MP3 manager. song titles and you click on something and it sorts by artists and stuff like that. If it did straight sorting based on the Ascii table, then all your song titles that began with an uppercase letter would come up to the top of the list, and then all the song titles that began with a lowercase letter would be at the bottom of the list. You really wouldn't want that, so your sort algorithms would need to be a little more clever than that. They've probably converted all to uppercase for the sorting option, you know, in its mind, even though it would display those lowercase letters. You know, that's one way around it. But very often you will see that if you name a song with a number at the beginning, 99 Problems, something like that, then it'll probably be up at the top of the list. And if you put some really weird stuff, like parentheses and things like that, they may even go up higher in the list. Or maybe the sorting algorithm in your MP3 player, you know, or your phone or whatever handles that and would do the first letter after the parentheses. You don't know. But as far as C++ is concerned, capital A is greater than lowercase a. Capital B or capital A is greater than lowercase b. And you may not think that that's right, right? Because B is a bigger letter than an A, supposedly. But we can prove that that's not the case. Come over here to our code. We're going to add just a little bit of stuff. If, and I'm using single quotes now because I want to force the use of letters. If capital B, end quote, is less than lowercase a, end quote, parentheses, cout, yes, cap B is smaller. And I'm not going to even add the else because I'm sure that that's true. Now watch it be proved wrong, but I'm sure that that's true. Yes, B is smaller. So, B's are smaller than A's. B's are less than A's if you're mixing case. How about if we made this a lowercase b? In that case, we are going to need an else statement. I'm going to make that a lowercase b, and I'm going to do else cout a is smaller, \n, end quote, semicolon. All right, and as a matter of fact, A is lower in the alphabet, so as long as they're in the same case, A is got a lesser value than B. And then things get really strange if you're using Unicode values and you're mixing, like you're comparing French letters to German letters and stuff like that. How's it going to sort that? I don't know. So lowercase letters have ASCII values, so a lowercase a is greater than an uppercase z. Ones are, in fact, smaller than twos, both in terms of digits and in ASCII values. We have talked about ASCII, right? Good, good. Got 3 different classes going that all meet right in a row, and my brain gets confused about which one we've done that in, which ones we haven't.
So what if you have like 11 and 12?
In that case, you're comparing strings. So if you have 11 or 12, we couldn't do it with single quotes. We'd have to do this. And if that's the case, let's go ahead and change it so that it is smaller. I wasn't expecting that. Maybe the slides explain why. Let's get down to comparing strings. Hopefully that's a new slide. Comparing string objects. Like characters, strings are compared using their ASCII values. So if you compare Mary to Mark, string 2 or name 2 should be less than. The characters in each string must match before they are equal. right, this one's bugging my mind. How about AA is less than AB? Is that true? AA is smaller, else AB is smaller? It should say AA is smaller, just like alphabetical order. Yay. All right. My faith is slightly getting restored. How about 1 being less than 2? So yes, 1 is smaller, else 2 is smaller. You know, I could have written this a little bit better so that I wouldn't have to keep changing every single thing, but whatever. 2 is smaller.
That should be right.
Not at all. Is 1 smaller than A? I don't know how it's treating the numbers in order to get those results. I'm just going to put a little note here that says, note, this is behaving oddly. It is saying that 2 is less than 1. And of course, if it didn't have quotes around it, it would just be doing math. I guess I should prove that before we go on, huh? Alrighty. Okay, good. So in this language, you can use equal equal to compare objects. And strings are objects. And if you've taken a Java class, you know what an object is. And if you've taken a Java course, you probably know that you cannot compare them with equal equal. In C++, you can, if the class that it is defined has overridden the equal equal operator. And that probably sounds like all Greek to me. Just know that it's okay to compare strings like this in this language, also in Python, but in Java you have to call dot equals. If you were going to compare some strings in Java, and I'm only mentioning this because I know that some of y'all have done it, you would do something like this. If, you know, name dot equals Bob. And that would work. But in C, you do this. If name equals Bob. Much cleaner syntax. And there's a reason why this works in C++ and it does not work in Java. And it's because operator overloading does not work in Java. You don't have the ability to say what equal equal does. But in C++, you can say what equal equal does for any particular data type. The conditional operator, also called the ternary operator. It's a slightly odd little beast. Why do I say that? Because you can do something like this. Let's declare two variables. Int temperature is equal to 33. And then string freezing. And then we're going to do this. And I'm going to put parentheses around it because it makes it easier to read, but the parentheses are absolutely not necessary. Temp less than 32, end parentheses, question mark. I goofed. I'm going to erase that and just completely retype it. Freezing equals, begin parentheses, temp less than 32, end parentheses, question mark. Frozen, end quote, colon, not frozen, end quote, semicolon. It's an itchy-bitchy little if statement written all in one line. What it does is whatever's in front of the parentheses gets evaluated, and if it's true, the first thing after the parentheses gets copied into that variable. Otherwise, the second thing after the question mark, or the thing after the colon, gets copied into the variable. So if we see out at this point that string freezing ENDL, and then we run it, we'll see the word not frozen. Why? Because the temperature is 33. 33 is not less than 32. If this was true, it would copy that value, frozen, into that string. But since it's not true, it's going to copy the second value, not frozen. And that's what we'll see when we run it. Not frozen. If we change this condition so that it's true, like negative 30, we know that negative 30 is less than 32. It's going to say that it's frozen. It says it's frozen. Now they show something really, good job, really almost what I consider perverse, but it's legal syntax. What this does is it evaluates this, and if that's true, it executes this code. Else it returns this code, executes that code. And to me, that's totally horrible that you're executing code conditionally, but it works. I would use it for values, like we did on my example, rather than actually executing chunks of code, because these could be function calls or anything. If you think that looks cool and you want to do it that way, that's okay. So that's called the conditional operator. The question mark indicates that this expression will be tested, and if the question mark is true, then this expression will be returned to the L value, to the left-hand value, else this one will be. So this is the same as writing this code here. If temp less than 32, freezing equals, quote, frozen, in semicolon, else freezing equals not frozen. Like that. These two chunks of code do the exact same thing, except one of them does it in one line and one of them does it in 4. So the expense of doing this is that it's a little bit more difficult to read. The advantage of it is that it certainly is terse. I could fit a lot more code on the screen than this one, which took 4. If I really, really, really wanted to and wanted to use bad programming style, I could do that, but that's kind of tacky. At least I got it down to 2.
Is there any situation where you want one over the other?
The vast majority of times I'm going to use this. But if it's merely to assign a value, this is perfectly good. And people will do that. You may see this a lot in code if out in the wild, But you never have to do this. The programming language works just fine if you don't do it that way. If you do it the way that we had here instead.
It's just kind of a shortcut.
Yeah, it's a shortcut. It's a shortcut for doing it. And they don't tell us why to use it. Parentheses may be needed in an expression due to precedence of the conditional operator. So here's the conditional operator at work. Let's see if we can spot it. How many hours were worked? And then they do arrow, arrow, hours. Determine the hours to charge for. Here they go. Hours is less than minimum hours, question mark. Set it to minimum hours. That's kind of neat. In one statement, you could set, but you could also just do that with an if statement. If I was going to do something like that, I'm going to delete this, so don't type it. CIN, arrow, 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 hours, and then if hours is less than min, hours is equal to min. Right? Same code. Far easier to read. I'm getting errors everywhere because I don't have these variables defined. Why not? Okay. So you could do it that way, or we could do their example. Hours is equal to hours less than men, question mark, men, colon, hours. So that if statement does the same thing as this. I have no reason why I would use the bottom one, but you can. Apparently, I'm just not clever enough to come up with an example of something you can do with the second one that you can't do with the first. And I think the ultimate answer is that it's a shortcut. Just like the for loop and the while loop are pretty much exactly the same once we start talking about them, or if you've had other. In this language and in Java and in C and C# and a great many languages, a for loop and a while loop, you can use them interchangeably. It's just that the for loop has a better syntax, a more concise syntax, kind of a shortcut syntax. Alrighty, I guess I'm going to leave all these examples here, even though they're not pertinent to our menu code. But I tend to leave everything on there. The switch statement. Now this is actually useful stuff, not the conditional operator isn't. You use the switch statement to select among several alternatives. In some cases, you can use them instead of if statements. I'll show you what I mean. Go back to your code here, and you see where it says if material equals -1 and all that stuff? It's actually going to be easier if we delete all this, but delete that section here. Delete all of this stuff. We're going to wind up typing a couple of things, but it gets hard to follow. Do this. Switch, parentheses, material. End parentheses, open brace, case 1, colon, cout, ice is cold, exclamation point, \n, end semicolon. And on the next line, do break. After that, do case 2, colon, cout, arrow, aluminum is awesome, \n, end quote, semicolon, break. And what about all the other cases? If they've entered bad data, default, colon, cout, arrow, invalid choice. Try again. \n, end quote, semicolon. That does the same exact thing that our code did previously, except instead of being written with if, else, ifs and stuff like that, it's written using a switch structure. Python didn't have a switch structure, so if you've only had Python, this is a new thing to you. Other languages like Java and C# and things like that, a lot of them do. And when I said for loops and while loops are kind of interchangeable, there's nothing you can do with one that you can't do with the other one. This one actually lets you do things that you couldn't support simply with if statements. You know, eventually, ultimately, you can do anything, but maybe I'll get to the point where I could show you that. So things to note. What it does is it evaluates the expression inside of the switch. And in this language, the expression has to be an integer type, or something that ultimately resolves to an integer, like a character. And then based on that, it will jump to the correct case. If material is 1, it runs down here and it prints out ice is cold, and then it hits the break. What does break do? It clears it. It jumps to the end of the switch. It doesn't jump to the end of the while, because this is the closing brace that is contained within. And in case 2, well, if material is 2, it jumps down here. It prints aluminum is awesome, and then it breaks and it comes down there. And if neither one of those were true, if it does the switch and it doesn't find any matching cases, it prints invalid choice, try again. So those break statements, are they necessary? Yeah, they are. Comment them out. Well, no, don't comment them out yet. We haven't even proven that the code works. Let's prove that the code works first. So run it and see if it still prints ice is cold or aluminum is awesome. Hey, neat, it's not doing anything. Oh, that's because we have some kind of CIN statement up here at the top. I don't see it. Right there. I'm commenting out all that code. The C in hours, the if statement, the if hours is equal to min, the out. Yeah, I'm getting rid of all that because that was messing us up. As a matter of fact, I can even get rid of the declarations. Okay. Strictly speaking, I should do the same thing for the frozen and not frozen things, but not going to bother. All right, so I run it. It says ice or aluminum. 1, ice is cold. 2, aluminum is awesome. 3, invalid choice. -1. Okay, goodbye. Be right there. Why didn't we put, remember how we had this break here, which caused it to exit the while loop? Why didn't we put material or case -1 in here? That would totally work. You can have case -1. There's nothing restricting cases to being positive. But the break statement would just cause it to leave the switch. It would not cause it to break all the way out of the while loop. Because all break does is it exits out the nearest closing brace. His nearest closing brace is that one, not counting if statements. Breaks don't work from if statements, but they do from loops, and they do from switches. All right. As an experiment, comment out all the breaks and run it, and see if it behaves any differently. So if I comment out brace, I hadn't started the recording, then when I run it and I type 1, it's going to print both ice is cold, and it's going to fall through, that's the technical term, also print that out. And since there's no break here, it's also going to fall through and do that. Now there are a very, very few times that you actually want fall through to work. You want it to happen. And if that's the case, I would actually put a break there. I would comment it out, and then I would put an fall through like that, and then maybe even explain why it's supposed to be falling through. Because otherwise, if any other programmer sees your code and they're supposed to be working on it, they're going to see that missing break. They're going to think you're an idiot, and they're going to put it back in, and it may break your code. So if you want fall through to happen, don't just delete the break statement, comment it out, and put a reason why. I don't want fall through, so I'm going to restore all my break statements so that it works correctly. Default doesn't need a break because it's at the end of the structure. There's nothing underneath it. However, I believe that you could put default up at the top, in which case you would need a break. Let's try that. Some languages do, some don't. So if I grab default, C out, and I put a break at the end and I paste it up here, is it still going to work just as good as it did? Let's find out. Even if it does work, just by habit, most people put it at the bottom. All right, it does work. You can put default wherever you want, but you better put break there if it's not the last one. Maybe just put break after default no matter what. That'd fix it no matter what. Okay. So what could we have done in our program? We would have switched material, and then based on the density, right? The density, if it was ice, is equal to 200 or something. I don't remember these values. And then if it was aluminum, the density was higher, right? And then if it was gold, the density was higher still. So we could modify our program to use switch cases rather than using if statements. And as a matter of fact, that's one of your homework assignments. Homework, modify the sphere density program to use switch case statements. Now don't do it now during the lecture. So here's the format. They show it happening on the same line. Here's the case, do that statement. Here's that case, do that statement. Now I'm not really aware of the fact that that can be an expression. I think that has to be a constant. I guess I'm going to prove that to myself. I'm going to go here and define a constant, int, but it's not going to be a constant. the number 1 is equal to 1, and then if I do case 1 here, is it going to accept that or not? No, see, it says wrong. Yeah. So when it said expression, that was implying that you could write a true expression. It has to be a constant. If I change this to constant, it'd probably work. That works. Here's a switch statement in action. This is enter A, B, or C. This one's a little bit moronic, but it's the same example we did. Enter into choice. Switch on your choice. A, C out. You entered A. Break. Case B. C out. You entered B. Break. Case C. You entered C. Now what would happen if we took all the breaks out and then they entered B? What would it print? It wouldn't print the A. It would jump to the B and then print everything. Yeah. But you have the idea. So fall through means that it would, like if they typed in a C, it would jump here, and if there was no break statement, it would do you entered C, and then it would you do not enter A, B, or C. If you enter A, it'll print all 4 messages. If you enter B, it'll print those 3. If you enter C, it'll print those 2, and if it's not any of them. So almost always you're going to be putting breaks there. It's very specialized cases where you won't. But those specialized cases is where switch statements do things that are much more difficult to implement with ifs and elses. So switch statement requirements. The thing that you're switching on must be an integer or something that evaluates to an integer. You know, if it's a function, it's got to be a function that returns an int. exp1 through expn must be constant integer expressions or literals. And they have to be unique. You can't do case 1 followed by another case 1. Default is optional but recommended for the same reason that putting a terminating else on your if cascade is a good idea. How it works: the expression is evaluated, the value of the expression is compared. If it matches, it jumps to that statement, they're calling it branches, and continues to the end of the switch. If no matching value is found, the program branches to the statement after default. And the break statement is used to exit a switch statement. If it's left out, the program falls through. But break can also be used inside of loops, as we have seen. So using switch and menu systems, we just did that. Right? You chose ice and it did one thing. You chose aluminum, it did something else. You display the menu, you get the user selection, you use the user input as an expression in a switch, and then you use the menu choices. Now I'm going to talk about something called a prime. No, skip that. I don't want to talk about loops anymore. More about blocks and scope. The scope of a variable is the block in which it is defined. Block being a pair of parentheses, a pair of braces. If I come in here and do this, say I put a block here, because you can pretty much begin and end a block anywhere in your code that you want, as long as you're in a function. And then I do this, int Fred is equal to 3. If I come here and I try to print out Fred, that's going to be an error. Why? Because Fred doesn't exist once that happens. Fred's lifetime, Fred's scope, is just in the block that he's defined in. Now, honestly, I don't know how this would happen if we did that. We removed the break, and then we compiled it. What is it going to say about all that? Yeah, alrighty. It says the initialization of the Fred is skipped by some of these cases. So yeah, that's bad. But
If you put it before case 1, would that be acceptable?
let's find out. Nope. But if you were going to do that, it'd be a good idea to stick it above switch anyways. So
Put it above the brace, will it still work?
if I put it here, it'll work.
What about under the switch but before the brace?
No. That will not work because this has to follow that. Exactly. You're not allowed to sneak something in between those two things. Very good idea, but that doesn't work. So the lifespan of a variable is the block in which it's defined. If I define a variable here, int x is equal to 3, then I can't get a hold of x out here. If I want to be able to get a hold of x out here, I better define it beforehand. There is something called global scope. If I declare a variable up here, it's available to every function inside this file. Python also supports the idea of global variables, but you have to do a little bit of trickery to get it to work. You just have to redefine that variable as being global in every function you write. In C, C++ is totally fine. Just stick it up there and then you can use it everywhere. It's considered poor programming, right? But you could use it. Like if you had 3 functions that needed to pass values around to each other, you could have a global variable and each one sets and reads that global variable rather than passing it around. It is bad programming. If you find yourself using global variables, think to yourself, my professor said it was bad, and he's probably stupid, but maybe in his one time he was right. So variables with the same name. Not a good idea. Sometimes you can get away with it. If I do this, int x is equal to 3, and then later on I try to change x is equal to 4, this is going to be a compilation error. Not going to let me compile it. Oh. Fred is undefined. Because I left that there. Let me put that break there while I'm thinking about it. Come back up here. This should not work. Those two things should not work. Watch it prove me wrong. Okay, nope. It says redefinition of different types. So you can't just declare the variable and then turn around and declare it as something else. In Python, you could get away with that. You could declare something and give it an int, and then you could turn around and give it a string and things like that. But it was not a strongly typed language. We were not giving them a type when we created the variable. Its type was being inferred by what was being passed to it. But if the variables are defined in different scopes, you can do that. Like what if I put a brace here? And this looks odd. Why'd you start a brace? You didn't have an if or a while in front of it. But you can do that. You can start a brace right in the middle of a function. Now this is okay. So if I print out x there, it's going to print out 4. And then when I come back out and I print it again, it's going to print 3. That may be almost counterintuitive. How could x possibly be 3 by the time we get here? Because this variable only exists between here and here. It can't even get a hold of this variable. It's called variable hiding, I believe. Maybe the book gives it maybe the PowerPoint gives it a cool name. But now that this variable has been defined in this block, it can't get a hold of this one that was defined outside of this block. And it doesn't matter whether it was declared as a global variable or just as a local variable inside that function. Since this one is the most recently declared one, it's the one that rules as far as that one is concerned. Now let me run it and make sure. But what I'm going to see is that it's going to print 4 and then it's going to print 3, even though it looks like it's printing the same thing. Yep, 4 and 3. So when inside a block within another block, you can define variables with the same name if you're within another block as the outer block. When you are in the inner block, the outer definition is not available, and it's not a good idea. They don't explain why. I'll explain why. What if this was a great big block of code over several pages, like that? And then I was coming in here and I thought, oh, okay, I see what I can do with x. I can set x to, whatever special value I'm supposed to be setting it to, and then later on, I'm going to be checking for that special value, so I'm going to come down here and do something special with x. That's not going to work, right? Because, let me delete all the intervening spaces that I just added. Just imagine that they're still there. I was using this variable, assuming that I was using one that was declared outside of that block. And it's possible that I wouldn't even get a syntax error. If both of these were of the same type, I wouldn't even get a syntax error. But I would, depending upon this being set to a specific value, but since this was declared there, I would be actually changing that one and not that one. So it can lead to very hard to track down bugs if you have multiple variables with the same name, regardless of whether they have different types of the same types. If they have same types, that's when it gets worse. Very hard to track down that problem. And so this one just shows it. We have an int number here. We ask them for a number inside an if block. For some reason, we declare another int number. And it says, now enter another number. CIN arrow arrow number. The second number you entered was that. Then we get back out of it, and it says your first number was that. Now that's what I did with that X. You know, I defined it outside of the block. I defined a new one inside of it. So when I printed it here, it printed the second value, and outside of it, I printed the first value. All right, that's the end of that PowerPoint. Our first exam is over chapters 2, 3, and 4. So we have hit the end of the material that I'm going to put on the exam. Doesn't mean we're going to stop here. We're going to blaze boldly forth in a new chapter.
So this only applies if you are reinitializing the variable. If you just write x is 4 inside that block instead of string x is 4,
then it behaves like you expect. Right, if I do this, and then I print out x here, and then I print out x again, it's going to be 4 in both spots.
okay.
Because it's only one variable, and so once it changes, it stays changed.
Okay.
But because I redeclared it, that's when we started getting into the problem. You know, we could embed it in 100 levels of braces, and it would still work just fine. Do people actually use this trick of just openly declaring a brace where you don't expect it? Well, yeah, and one reason to do that is so that if you declare any variables, they're only existing from there to there. Now, why would you want to do that? Because it gets really annoying when you want to redeclare a variable. Like, what if I have this variable up here? I want to calculate some kind of sum. So I do int sum is equal to 0. And then I do some copying and a pasting of code, and I create another sum variable. I'm going to get an error there because it's a redefinition of an existing variable. And then I go, okay, would you like to continue? No. And you go, okay, drats. I have an error. I want to find out what it is. Multiple initializing. And I go, oh, shoot. I have a whole bunch of code that depends on this variable. I don't know if I can reuse it. I don't know if I could change its value. Because, you know, then you start scrolling up and down and figuring out whether that, you know, if this was inside its own block, for whatever purposes, you could use it. And then when it hit the end of that block, that variable would go away. So, when we just said it's a bad idea, if you're using it defensively like that, it's not such a bad idea. If you declare a block and then define all your own special variables, like if we'd put some inside there, that's totally cool because that variable is going to be gone as soon as we're done using it. Hope that makes sense. And if it doesn't, that's okay. This is the one time when I think it's actually cool to have multiple variables within the same names, is if you block them off like that. Because if we get down here, we're going to know immediately that sum doesn't work, right? Because it was defined within an inner block. And ultimately, that is no different than just doing something like this. Right. We have an inner block there. We defined a variable called sum there. No problem. That looks normal to us. The only thing that didn't look normal about it, maybe, is the fact that we weren't putting an if statement or a while statement in front of that block. I don't know whether to leave this stuff in here or not. I guess I'm just going to put down here, cannot access sum because it no longer exists. Why they call it scope, I don't know. You have a hunting rifle, you can't see the deer in your scope, then you can't access it, you can't shoot it. I'm not sure. Okay. Other people call it lifetime. The lifetime of the variable is just between where it is defined and the end of the block of code in which it is defined. And that's why a global variable works, because it's not inside any block at all. So it can be used by all the functions, including main and any other functions you add to the code. Alrighty guys, why don't we come back here at 8:35. I'll be thinking about what kind of homework assignment we need to have over chapter 4 besides the one that I just gave us.
So we're gonna turn that in twice, once with the switch?
That's correct. I'm going to make another Dropbox that has a switch version of it. Alright guys, the other homework assignment that we're going to have due, or that I'm signing from today, surely everybody in here is old enough to have used one of those old pre-smartphone cell phones, where if you wanted to send texts, you did so by pressing repeatedly on the keys. And if you wanted to say hello, you'd press 4, 4, then you'd find the E, and you'd press 3, 3, and you'd find the L, and you'd press 5, 5, 5, and then 5, 5, 5 again, and it'd make another L, and then if you wanted the O, you press 6, 6, 6. Right? We've all done that? Or at least we all understand the idea? All right. In a couple more years, I'm going to have people look at me like I'm insane when I show them this. Okay. So, on the old-fashioned non-smartphones, you had to send SMS text messages by typing in sequence of numbers. To make an A, you had to press 3. What? Is that why nobody did this assignment right? No, I'm kidding. All right. You had to press the number 2. To make a B, you had to press 2, 2. I was on cough syrup, apparently. To make a C, you had to press 2, 2, 2. Notice that they left out 1 completely. Why do you think that might be? It's because 1 is a long-distance activator. And these numbers, these letters, were invented before text messaging. Back in the old days, if you were going to dial somebody and you use those word prefixes, like where do you live? Well, I live in Whitfield 3421, right? And so Whitfield would be W9 4H, and then you type in the rest of the phone number. And one of Midwest City's codes was called Regent. And so you'd give your phone number as Regent 72222. And a Regent, you'd look it up, that's a 7. And then the E is a 3. You see, and if you're Midwest City, you may have a 73 phone number, 7 or 732 or something like that. So that's where the letters initially came from. And they didn't stick any on 1 because 1 is the long distance activator, which meant that they had to cram a whole bunch of them on 9. I guess they figured that not many words begin with W, X, Y, or Z, so that it was safe to do that. Why they didn't use 0, I don't know. You could have stuck some on 0. Is that where punctuation was used later, if you wanted to type in a comma or something?
I think 0's for international, isn't it?
Yeah, that's right. So that would be why, so that you could trigger an international call without doing that. Okay, so anyways, that's what we're going to do today. I got these totally wrong. For a D, you press 3. For E, you'd press 3, 3, and so on. If you look at this keypad, you'll realize the instructor was messed up. All right. Okay, so to get a Z, you had to type 999. That's finally I got one. So, write a program that will ask the user to enter a letter, then press print out, then display the series of numbers that would be required to send that letter. So if the user enters M, the program will display 6. And that's boring. Let's make it N so that it displays 2 things. Okay. Now what would be really cool is if we let us type in an entire message, right? Hello there, and then it would print out the entire series of digits. But we don't know how to turn strings into arrays of characters yet, so we're just going to do 1 for now. This is a homework assignment, but we may as well start off just doing part of it in class. Now you could do this with if statements, right? If letter is equal to C, print out 222. If letter is equal to N, print out 66. That's boring. Let's print it out with case. Let's do it with case, switch case. And then maybe we can even use some clever use of fall through in order to get something cool to happen. Well, let's go ahead, and I don't know if you want to start a new program or just stick this up at the top of main. Tell you what, why don't we make a new function? We're going to call it void. We haven't been doing a lot of functions yet, but hopefully you get the idea real fast. A function is just a named block of code, and we're going to call this new one from main. Okay, so I'm going to call this one text message. Void text message, parentheses, in parentheses. Notice it looks a lot like the declaration for main, except it's not an int. Void just means that you don't have to put a return statement at the bottom. So system, just like we did on the other one, parentheses, pause. Now the top line of main needs to be a call to that text message function, or else it won't do anything. Text message, parentheses, in parentheses. Then if we wanted to kill the bail out right then and there, we could stick a return there. But if we want to run the rest of the code, we better comment that out. But the rest of the code has to do with all that ice and aluminum and stuff like that. So that's why I set it up like that. Rather than just shoving all of our code in the top of main repeatedly like we kept doing, we're putting it in a new function. And that way we can invoke that function, and then we can bail out of main, and it will no longer run the rest of this stuff. Will you do that normally? Nah, you're not going to want your program to skip a bunch of stuff. To be really cool, we could make it optional, right? Press A to run text message program. Press B to do sphere density and stuff like that. That would be cool, but we're not going to do that. Okay. Do we want to put this in a big loop so that they can keep doing it over and over? I think that would be kind of neat. Did we demonstrate that? Yeah, well, let's do that. So, while true, let's see out, enter a letter of a text message. Colon, space, end quote, semicolon. We need a variable to read it in, so I need to cheat and go and look at my cheat sheet on the next page. Alright, so instead of defining it as a string, we're going to just define it as a single character, because you can't do a switch case on a string in this language. In Java you can't. So, character, letter. And let's read into that variable. CIN arrow, letter. And I kind of like my variable declarations to be the top of the block, so I'm going to cut that char letter and move it up to the top. It'd be neat and nifty slick if we could convert that letter to like an uppercase letter so that we didn't have to double check what we're just about to do. But I'm going to not bother with that. So we're going to switch based on the contents of that letter. Now that we have a letter, they've typed in an A or a B or something like that. Let's do this. Case, caps A, colon, case, single quote, lower case A, end quote, colon. What does that mean? That means either one. And you know what? I'm probably going to be wrestling with it. For some reason, it wants to tab it like that. I like it being tabbed over one more. So, okay. And then I'm going to see out arrow 1. Arrow. Now, I'm not going to even do an ENDL. I'm just going to do that. and then break. Here's a reason I'm not going to do ENDL. That'll become clear later. I'm going to take advantage of fall through to make this a little bit easier to write. Okay, so A was not a 1. What was an A really? 2. Okay, and so now I'm going to add a couple cases for B. Case, quote, capital B, end apostrophe, colon, and also the lowercase b, case, lowercase b, end apostrophe, colon. Notice that I lined them up side by side. There's nothing requiring you to stack them like I did here, and I think it's prettier if you line them up side by side, so I'm going to go and edit my cases up here for A as well to kind of match that style. And so, Cout 22. And then break. Let's go ahead and do C and D. Case C colon, case lowercase c colon, Cout arrow arrow 222, break. I'm going to do D, and then I want y'all to continue to do E and F. So D is a 3, case apostrophe capital D, colon, case lowercase d. Do you see how we're taking advantage of fall through here? We're doing both of these cases, and even though there's no code between here, it is taking advantage of fall through, because if it was an A, an uppercase A, it would ignore that case and then go down. If it's a lowercase a, it jumps there and does that. So Cout arrow arrow colon 3 3 3. What am I doing? A single 3. Semicolon. And I'm going to put a default to handle all other cases. Default colon Cout. I'm just going to see out the letter. That's probably not the right thing to do. We probably ought to tell them they typed in something invalid, but maybe that'll look cool. Okay, now we made this an infinite loop. How are we going to make it stop? A period, a tilde, a slash, a space. Something's got to make it stop if we're going to use a loop. Anybody have any suggestions for what our sentinel value could be? I can, but that would only let us do one letter at a time. And I'm hoping that the way it'll work is please type in a letter or -1 to quit, except -1 won't work because it has to be a single keystroke.
Oh, so it's going to put the whole sequence.
It would be neat if we made it to do the whole sequence, but at least it's going to keep looping until the user quits. Tell you what, why don't we avoid that? Why don't we skip that for now and just see if our program works up to the point where we've got it. It won't let us exit, but we'll figure out how to make it exit in a minute. And you're right about putting the break outside the after the switch. We'll need to do something like that. We'll probably actually put it beforehand. Enter a letter of a text message, A, 2. Enter a letter of a text message, B, 2, 2. Now the output's looking sloppy. 2, 2, 2. 3. Okay. The output is looking far too sloppy. I need to put a Cout ENDL here at the bottom. So after my switch, and I'm going to put a comment here, in switch. I think that if you have a block of code that spans more than one visual page, it's a good idea when you end the block of code to explain what you're ending, whether it's an end diff or an end switch or an end while, something like that. Okay. And now I'm going to just print out a ENDL so that it looks a little bit wetter. It looks a little bit better when I run. A, B, B, C, D, E. D looked funny. I had to have entered something wrong in my code to handle D. Yeah, I did. Oh, is that it? I don't have a break there. You're right. Accidental fall through. Okay. I'm happy with the way that is implemented. But I'm going to make, I will also want us to have the option of stopping it. I think I'm going to make it slash to quit. No, I'm not liking the slash idea. Yeah, why not? Okay, enter a letter or slash to quit. And so that needs to be the very first thing we check. If letter is equal to single quote slash end quote break. I think that'll do what we want it to do. What we really like is to be able to type a whole string and then have it print all the numbers. But like I said, that involves something that we haven't learned about yet. Okay, that's cool. I typed in DSF and it printed D. I thought I handled D. I really slopped it up on D, or is it because I typed in multiple things? That's interesting.
Yeah, it looks like it executed it for every letter. What happens if you type ABC?
Yeah, why am I typing those letters? Neat. So, this is my text message. Kind of neat. It's actually almost kind of working, but not really. Okay, so anyways, we could use fall through to make this even slightly cooler. And what do I mean by that? Take this break statement out and just print out a single 2. No, this isn't going to work the way that I wanted it to do. I'm going to undo those changes. Take that entire I'm just going to rewrite it to show you what I'm thinking about. And you don't have to do the rest of it. Case, capital C, colon, case, lowercase c, colon, C out, a 1. And that was supposed to be a 3. That's why I kept printing the wrong one.
Yeah, if you do them in reverse,
Yeah. And in case B, colon, case, lowercase b, colon, C out, another 1. And in case A, colon, case, lowercase a, colon, C out, another 1, and then break. So why did I do that? Because if you do fall through, what's it supposed to do if you press C? It's supposed to do, if you press 3. If you do C, you have to do 3. I did 1s again. Okay. If you press C, it's going to print 2, it's going to fall through and print out another 2, and it's going to fall through and print another 2, which is what we want, and then hit a break. But if you press B, it's only supposed to do 2 B's, 2 2's. So if you type B, it comes in here, it prints that 2, it prints that 2, and it breaks. But what's an A supposed to be? A single 2. So if you type in A, it jumps there and it breaks. You see what I mean? Either one of these works just fine. You'll want to do it that way with the sneaky fall-through business. We ought to actually put, like I said, put a break and then comment it out. And I'm going to copy and I'm going to paste that. I'm not really explaining why, but at least I'm letting the next person go to know, understand that I meant to do that. Whoops, not that one. Okay. Or let's just do this one. Case, let's do this one the old way, the other way. And if you've been stopping because I was getting too weird, pick it back up at this point. Cout arrow 3 3. And then an F is 3 of those guys. And what did I forget? I forgot some break statements. All right, so D, E, and F ought to work. A, B, and C ought to work, and the rest of them aren't going to work. You know, maybe we ought to print something better than just Cout letter. The reason I did that is so that if you typed in periods and question marks and stuff like that, but meh, I'd rather print out an error message. Okay. So if I'm right, if this works, what I would like for you to do is to go ahead and do the rest of the alphabet. Really shouldn't take very long. What do I mean by that? You could just copy a block of code and change, you know, G, H, and I, you know, and so on. You could handle the 4s, you could handle the 5s, you could handle the 6s, and so on. We could probably get it done in 5 or 10 minutes, and then you knock out a homework assignment, because I am going to post this as a homework assignment. There were build errors. Well, I goofed. All righty. IntelliSense expected a semicolon. Yeah, you're right. Put a semicolon there like I didn't. Okay. So if you feel like doing it that way, that's cool. If you feel like doing it how I did C, B, and A, that's also cool. Can you see everything that I did? Not until I zoom back out, and in that case it's going to be hard to see, but okay. That makes sense? Y'all willing to do the rest of the letters, G through Z?
I'm missing that top code above it.
That's one of the things that we added there. All right, let's go ahead and do that. There. So why don't we blip over and pull out chapter 5 because we still have valuable time. I don't know why chapter 14 is tucked where it is. If you're looking at the PowerPoints, that looks rather odd. Let me pull it out of that place. Stick it somewhere else. Okay. All right, so loops. We've been talking about loops. It's timely to start lecturing about them. Plus plus adds one to a variable. Typing val plus plus is the same thing as typing value is equal to value plus 1. You can put it before the variable or you can put it after the variable. It means dramatically different things if you do that, but they look almost the same. Let me see if I can give you a written description of what the dramatically different part. Not that dramatic, it's not like a movie. Okay, plus plus is the increment operator. So, say you do this, C is equal to 3, and then you do C++. What do you know? That's what the language is named after. And then you C out C. What's it going to print out? It's going to print out 4. Because C was 3. We added 1 to it. So, you know, x plus plus is the same as writing x equals x plus 1. That's the postfix version of it. If you use the prefix version of it, it does something different. Let me rewrite this. X plus plus uses the value of x and then increments it. Plus plus x increments x and then uses it. What does that mean? If we do this, x is equal to 3, C out x plus plus, ENDL, it prints out 3. Doesn't look like it's going to print out 3, right? It looks like it's going to print out 4. But it prints out 3. Why? It uses that value of x, and then it increments it at the end of the process, like when it hits a semicolon or whatever. The whole statement is performed before x is incremented. All right? Well, what if we do it the other way? X is equal to 3, C out, arrow, arrow, plus plus x, arrow, arrow, ENDL. That's going to print out 4. Maybe that looks like what you were expecting it to do based on what I'd already said. It increments x and then uses it. So it's the first thing that happens in the statement. X is immediately incremented and then it is used. When the plus plus follows the variable name, it is the last thing that happens. This value is used, so it prints out a 3, and then later it's incremented. But when it hits the end of the when it hits the semicolon at the end. There will be a couple of test questions worth a couple of points based on that idea. So I'm hoping that the textbook hits it again. Let's find out. Well, minus minus is the decrement operator. It subtracts 1 from the variable. So val minus minus is the same thing as val equals val minus 1. And also, you can use it before the variable or after the variable. Same rules apply. If it's before the variable, it means update the variable, subtract 1 from it, and then use it. If it's after the variable, it means use the variable and then update it. Now, if it's on a line all by its lonesome, it doesn't matter which happens first. So if your code just looks like this, x is equal to 0 while x is less than 10, C out x, and then increment x, it doesn't matter whether you put the plus plus in front of the x or after it, right? It's still going to get increased. There's nothing else using that value in it. There's no complicated expression. It's just going to increase it. So you can put the plus plus in front of it. In terms of writing the fastest code possible, if you use the prefix version of plus plus, the code runs a little incrementally, a couple cycles faster. The technical reason for that, I don't understand why, but if you write it like this, then this memory address has to be accessed more times than if you prefix it with a plus plus. And the fewer memory accesses you do, the faster your program runs. So, as a matter of course, if I was smart, I would always do that. Old habits die hard. Works either way.
If you do the prefix, can you put it within the CI statement?
I could, exactly. I could do this and it would work just as well. And you'll see a lot of C programmers write it like that. I tend not to do that. I tend to put the increment, the update to the variable on its own line just for absolute clarity. But it's a totally cool way to do it. So prefix versus postfix, yeah, this is where I was explaining it. They could be used in complex statements and expressions, not just on their own line. So in prefix mode, the operator is incremented or decremented and then returns the value of the variable. In postfix mode, the operator returns the value of the variable and then increments it or decrements it. So as I was saying, if we do this, where was that? C out x plus plus, it prints 3 because it was given 3, and then it changes it to 4. So it prints 3, then x is incremented to 4. X is incremented to 4 and is then printed. And here's just several examples of that. Value is equal to 12. Cout val plus plus. I wish I'd erased all of these. What is it going to display? It's going to display 12 because the increment doesn't happen until the statement is done. But then it is incremented, and so value is equal to 13. Cout is equal to plus plus val. Well, it was 13. This immediately increments it to 14 since the plus plus is a prefix, and then it displays it, so to print out 14. Num is equal to minus minus val. Well, val was equal to 14. Since this is a prefix, it immediately reduces it to 13, and that is what's stored in num. And then again, num is equal to val minus minus. Well, val was 13, so it gets copied into num, and then when the whole statement is over, does it get reduced down to 12? All right, this is looking kind of crazy. Would I write that expression? Probably not. Result is equal to num1 plus 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 minus minus num2. Whatever. Must be applied to something that has a location in memory. You can't add two numbers together and then do plus plus. It's not like this takes the result of a number and then increments it. Just like you can't do this. X is equal to 3 plus plus. It's got to be a variable. It can't be a constant like that. And it can't be the result of an expression. It has to just be a single variable. And it can be used in relational expressions. And this is not an uncommon thing to do. If plus plus num is less than limit. Pre and postfix operations will cause different comparisons, right? Because this would be incremented before it checked to see if it was greater than limit. And if you moved them over there, then the comparison would happen and then it would check it. So introduction to loops, the while loops. We've kind of been using them. It's a control structure. There are several different kind of control structures. There's the decision, which is flowcharted with a diamond, the if statement, and then also the while. The loop is a control structure. We repeat statements. The general format is while expression, do some statements. It could be one statement, or it could be a whole block of statements that you enclose in curly braces. Now, there's absolutely nothing wrong with going ahead and, even if it's just a single statement, putting it in braces. That's my preferred practice. Why? Because you may want to come back and add some code to it. Let me give you an example of something that would... Say you're a Python programmer and you think that everything is based only on indentation, and you saw this code. While x is less than 3, I don't know, Cout x minus minus, arrow, arrow, ENDL. And then you had something else under here, Cout, done, like that. You might think that both of these statements are part of the while block. Python programmers would. In Python, it would be part of the while block. Although in Python, you'd end this with a colon, right? But no, it's really treated by the compiler like it's like that. Let me give you a better example. While x is less than 10, Cout x, and then x equals x plus 1, or x plus plus. And we initialized x to 0 here. Looks like good code. X is less than 10, so print out x. But does it do this statement? The answer is no, because it's not part of a block, and if it's not part of a block, only one statement is performed. The body of the while loop is just that. So it's just like it was written like that. That's an infinite loop, because it has no way to stop. The x variable is never changed. So if it was less than 10 to begin with, it will always be less than 10, and you just have to cancel the program to get it to stop. It'd print the same number a million times in a row.
So if you put the plus plus after the x and the Cout,
Then it would work.
is that considered one statement?
Yeah,
Even though it's performing two actions?
correct.
Okay.
Yeah, that would do what this code was designed to do. And so that's why some C programmers like to write terse code, and they structure it like that. I think that's slightly more difficult, so I didn't write my code like that. But you'll see a lot of examples out on the net of people doing that. But as a matter of course, I just tend to do that unless I have a good reason not to, and my reason in class is just to get as much code on the screen as I can at once. Not the best reason, but it's mine. Okay. So, as long as this expression is true, the statement is repeated, this block of code is run, and then it comes back up and the expression is reevaluated. This is called a pretest loop because it is tested before the block. There's another kind of loop called a post-test loop. You Python programmers have not used a post-test loop. The structure does not exist in Python. You Java guys have. It's called a do loop. If this is true, it does a statement. Now, if this is false to begin with, it doesn't even come in here. Like it's an if statement. You know, if this was if x less than 10, but x was greater than 10, it wouldn't even run the statement. So if it's while x is less than 10, if x is not less than 10, it's not going to run the statement. You know, it's not going to get past the gate to come in there and enter the body. So your while statement generally takes this format. You usually have an initialization step above it. You got to initialize some variable. And then you have a test. This is our test. And then you have an update. Something has to update it so that the expression changes. If we go back to my code here, we had an initialize, we had a test, and then we had an update. Yeah, this was the body of the code, but it happened to be updating the x variable as well. I'm going to rewrite this so that this is on its own line. It's a little bit clearer. And so that's the update. Without the update, it's an infinite loop. If nothing ever changes x, but it went in here in the first place, it runs forever. You can monkey with that syntax by using a break statement. If you have a while true loop, you don't have to initialize anything. You don't have to have a condition. It's just while true. You don't have to have an update, but you better have some break statement that causes it to bail out, some kind of if statement down there. So it's almost a different beast. A while true is just, kind of a different beast. Otherwise, initialize, test, and update. And we're going to compare this to a for loop. A for loop lets you do all three things at the same time. Here's an example of a loop that counts from 0 to 9. Why do I say it counts from 0 to 9 and not 10? You see a 10 here. But what happens when x is 10? It's no longer less than 10, so it bails out of the loop. So it's going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a for loop that does the same thing. For x is equal to 0, keep running while x is less than 10, x plus plus. And then cout x, ENDL. This has all three steps of the same in one line. That's the initialization step. That's the condition. And that's the update. Now I guarantee that when I'm demonstrating code up here, I'm probably at some point going to leave the update off. And I'm going to run it and I'm going to have an infinite loop. It happens multiple times every semester, and it's not because I'm trying to prove a point. It's just because I forget to add the update to my code. Right? Especially if I have more than one line of code. It's easy to remember if it's only 2 lines of code. But if it's 20 or 30 lines of code, I may forget to put the x plus plus down at the bottom. But if I have a for loop, I never forget to put the x plus plus, or whatever the update is. It could be c minus minus. It could be a call to a function. It could be anything. But it should be something that updates it so that eventually this condition becomes false. Now, if you like making weird syntax, you can skip parts of this stuff. You don't have to initialize it, just like you don't have to initialize this up here. You don't have to update it. You could depend upon the body of the loop to update it. But by the time you've done that, that's just a while loop with a more mangled syntax. So sometimes people find weird ways of doing things. Alrighty. The logic of the while loop. Now, when I teach flowcharting, I don't teach it like this. Usually I have the line coming from the statements, going down, and then back up diagonally into the expression. And why do I teach flowcharting like that? Because if I draw a loop up like that, it makes people think that they can stick extra blocks right here. And you can't do that in a structured loop language like C++ or Java. The loop can only repeat the stuff inside the blocks, right? So, but this is the way they demonstrate it, and this is the way most textbooks demonstrate it. So, as long as the expression is true, repeat that block of code. And this would be the stuff that's inside the braces. When I teach flowcharting, I actually put the word while there, or if there, depending upon what kind of decision it is. So, int number is equal to 1. While the number is less than or equal to 5, print hello, and then add 1 to number. So how many times is it going to print hello? You can just count it out. Is it going to print hello when the number is equal to 1? Yeah. How about when it's 2? How about 3? How about 4? Is it going to print it for 5? In that case, it is. Once it's 6, it's no longer going to print it. So it actually did print it 5 times. Now, if this was just number less than 5, it would go 1, 2, 3, 4. But then 5 is not less than 5. And so it would stop at 4. So a lot of times you'll see people write loops like this. Int x is equal to 0 while x is less than 10. That does iterate 10 times. It just iterates from 0 to 9. Other people want to do this. Int x is equal to 1 while x is less than or equal to 10. That also iterates 10 times. This is more common in a lot of places because if you're accessing what are known as arrays or lists, they're 0 based. The first element in the list is 0. It's like you have a whole bunch of people lined up to go in the movie. Instead of handing the first person ticket number 1, you hand them ticket 0, and then 1, and then 2, and then 3. So with 0-based indexing, it makes more sense to write it like this. Why wouldn't I make it less than or equal to 9? Because that was going to iterate 10 times, but that makes it look like it's only going to iterate 9 times to the casual observer. So, that's why I will tend to write it like this. But it makes it slightly harder to read anyway, in a way. This tells you the upper limit really easily. Oh, it's going to keep going all the way through 10. This one you have to kind of remember, oh yeah, it stops before 10. But you Python programmers saw that. You saw something that looked like this. For x in range 0, 10. And what did that do? It counted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Same idea. You couldn't construct a range that used a less than equal operator. All it ever did was use less than. Same idea. Obviously, a block of code can consist of more than one statement. Print hello, add 1 to it. Keep going while number is less than or equal to 5. So, int number is equal to 6. While number is less than or equal to 5, print hello. How many times is hello going to be printed? Is number less than 5? No, it's 6. So it's not going to even enter the code at all. Just like that was an if statement. If number less than or equal to 5, is the number less than 5? No, it's not. So it wouldn't print out hello. The same is true for while, because it is a pre-test loop. The test happens and then the body of the code executes. There's a post-test loop as well. I'm going to go ahead and introduce it to you since we're on the topic. X is equal to 6. While x is less than or equal to 5, I'm going to start writing Python. Alrighty. Cout x and then x plus plus. This will print 0 times. But what if we do this? X is equal to 6. There's something called the do loop. The do loop works like this. Do this chunk of code while x is less than or equal to 5. Semicolon. Now, if we started x off at 1, it would make more sense. cout x. What is it going to print? Well, x is equal to 1. So print them out. Oh, I never incremented him. Print it out, increment it. Now x is equal to 2. So is 2 less than 5? It sure is. It comes back up here and it prints it out again. Adds 1 to it. X is 3. Prints it out, updates it. X is 4. Prints it out, updates it. X is 5. Is 5 less than or equal to 5? It still is. Come around, print out 5, update x. X is now 6. It falls through the loop. It's called post-test because you do the body of the code before the expression is ever tested. So this would, in fact, print out 1, 2, 3, 4, 5, as you could be expected. But if you set it to an invalid value, it still enters the loop. What if this is equal to 2,000? What is it going to print? It's going to print the number 2,000. Why? Because there's nothing stopping it. There's no expression here. There's no gateway. So it comes in here, it prints out 2,000, it adds 1 to it. X is now 2001. And then it checks, is x less than or equal to 5? No way, 2,000 is not less than 5. So it bails out of the loop at that point. So your general rule of thumb is, use a do loop if the code must execute the body of the code at least one time. That's when you want to use it. Use a while loop, comma, otherwise. Now we're going to expand upon that. But if this is so important that it has to happen no matter what the initial value of x is, you make it a do loop. If it's okay for it not to process the body of it, you make it a while loop. That kind of making sense. I don't ask often enough to make sure that our concepts are going okay. So watch out for infinite loops. The expression has to be able to become false. Otherwise, it has no way of stopping. It's called an infinite loop. It will repeat until the process is terminated. We set up infinite loops with a while true loop, but we put in a break to let it bail out of it. So this is an infinite loop. While the number is less than or equal to 5, print hello. But nothing ever changes numbers, so it never stops. So you can use the while loop for input validation. What does that mean? You inspect the data, make sure it is good data. And if it's not good data, then you keep making them enter it until it is good data. This will probably be the last thing we do today, but I do want to demonstrate that. So find the top of main, wherever it is, okay. And what we're going to do is we're going to see out a message that says, please enter a number between 1 and 100. Now we need a variable to hold our number in, so int number, and then CIN into that number. But now we're going to write a while loop. And if the data is wrong, we're going to yell at them and make them enter it again. So, while CIN is less than 1 or, and what in the world am I doing? I'm just deleting that. While number is less than 1 or number is greater than 100, because those are our error states, right? If it's 0, it's invalid. If it's greater than 100, it's invalid. So while that condition is true, cout invalid number must be between 1 and 100. And then cout enter the number. And then read back into the number variable, CIN arrow number. After our while loop, we can finally actually use that data. Cout, yay, you entered valid data. Go you. And let's do a system pause there. This is a data validation loop. It's got one of those things in it I don't like, which is that we have duplicated code, right? We're doing this CIN number in 2 places. I hate doing that, but this is called a priming read. You have to read the number in first outside of the loop. You got to prime the pump. And then inside the body of the loop, if something has gone wrong, you've got to ask them for it again. And if you do that while true break business, you can get away with not having the priming read. And I know I mentioned the priming read when we were talking about the text message, but we didn't actually have it in example in code. All right, please enter a number between 1 and 100. I'm going to enter bad data, -10. Invalid number must be between 1 and 10. 1 and 100, enter the number. Obviously, I forgot a \n somewhere. How about 101? Nope, you fool. All right, now I'm going to enter some good data. 5. Yes, you entered valid data. Go you. Okay, so you can use loops for validating data. Sometimes what I do is I stick this in its own function so that I can call it over and over. And if I really wanted to be careful, I would inspect the data to make sure it was a number, right? So that if they type in a string, it doesn't just go berserk like we've seen in the past, where if they type in a word and it loops infinitely. And in a previous chapter, we saw how to fix that, and I've almost forgotten how. Oh, that's right. There's a flag that indicates whether it's good data, whether it's bad, whether we're in an error state. And if we are, we need to flush the buffer. We need to ignore, and then have it loop again. All right, everybody got our little while loop data validation routine working. Let me put a comment saying that that's what we did here.